Welcome to video 3.4, value mixture problems. So for the first four examples, I'll just set up the equations. For the fifth example, I'll set up and solve. Otherwise, we'll be here all day. And the hardest part is the setting up anyhow. All right, so example one. Two mechanics work in a car. The first mechanic charges $75 an hour. The second mechanic charges $105 an hour. They work for a combined total of 15 hours, and they charge a total of $1,275. How long did each mechanic work? So that's how the problem will appear on Alex. What you need to do is this rest. Okay, so I like to say, how long did each mechanic work? The first mechanic is how many hours? The second mechanic is how many hours? Because then that gets me into defining the variables and the units will help me with the sum equation. All right, so for my variables, why don't I let F stand for the hours of the first mechanic? So F equals number of hours of the first mechanic. And why don't I let S, I like to borrow my S's, equal the number of hours of the second mechanic. Okay, now, once I've defined the variables, I'm now going to go to the sum equation. So in all of these, there's going to be a sum equation and a rate equation. So I've got hours and hours. Let's see if there's a summing of hours anywhere. Oh, combined total of 15 hours. So F plus S equals 15. That'll be your first equation. Then the rate equation will involve the other sentences. So I go to the other sentences, I see he charged 75, he charged 105, and a total of that many dollars. So it's going to be 75F plus 105S equals that 1275. Okay, we'll do a few more of these. Example 2. Kim family used a sprinkler for 15 hours, Gonzalez family for 40 hours, combined total output of 1775 liters of water. The sum of the two rates of water output was 60 liters per hour. What was the water output rate for each sprinkler? So that's what you'll see in Alex, and then you'll have to do all of this rest on your own. So water output rate for each sprinkler, so I said the Kim family output rate is how many liters per hour. Gonzalez output rate, how many liters per hour. Again, when you see a rate, it should be per unit time, typically. Okay, variables. Well, let's use the variables K and G. So K equals liters per hour of the Kim family, and G equals liters per hour of the Gonzalez family. Okay, so these units here, liters per hour and liters per hour, I'm looking for a summing of those in these words. Let's look at all these words. Oh, liters per hour sums 60. So K plus G equals 60. Now I'm going to look at the other sentences to get the rate equation. So I'm going to have a 15K plus a 40G equals a 1775. Okay, a couple more examples. Example 3. Family has two cars. First car gets 15 miles per gallon of gas. Second car gets 20 miles per gallon of gas. During 1 week, the two cars go a combined 1125 miles. Total gas consumed was 65 gallons. How many gallons of gas consumed by each car? Again, that's all Alex will show you. You've got to do the rest. So, gallons of gas consumed by each car. So I like to write down first car equals how many gallons of gas. Second car equals question mark gallons of gas. That'll help me define the variables and get that sum equation with the units. Variables. Let's use F and S. So F equals number of gallons for the first car, and S equals number of gallons for the second car. Okay, then the sum equation is going to involve gallons. Let's look at all the words and see if we see a sum of gallons. Hey, right there. So I'm going to say F plus S equals 65. F plus S equals 65. Then I'll use the other sentences for the rate equation. So I'll say 15F plus 20S equals that 1125. So 15F plus 20S equals 1125. Whew, let's try another one. Okay, example 4. The Rogers sprinkler has an output rate of 25 liters per hour. Robinson sprinkler output rate 40 liters per hour. Families use the sprinklers combined total of 55 hours. Total output of water 1900 liters. How long was each sprinkler used? Again, that's what Alex will show you. So how long was each sprinkler used? So you got to be thinking of the term hours. So Rogers sprinkler equals how many hours? Robinson sprinkler equals how many hours? Again, that unit will help us immensely. Now let's be careful for defining the variables. They both begin with the letter R followed by O. So I'll just go to the next letter and call it G and B. So G equals number of hours for Rogers family, and B equals number of hours for Robinson. Okay, sum equation. Okay, let's look for a summing of hours anywhere in these words. Hey, got it right there. So G plus B equals 55. G plus B equals 55. Then let's look at the other sentences for the rate equation. Hey, 25G plus 40B equals 1900. So 25G plus 40B equals 1900. Okay, now for the final example, and this is how it'll appear on Alex. Example 5. So a truck is transporting boxes of two sizes. Large boxes, 60 pounds each. Small boxes, 20 pounds each. 125 boxes in all. Truck is carrying a total of 5,300 pounds in boxes. How many of each type of box is the truck carrying? So step 1, I like to write down what's going on. How many of each type? Okay, so number of large boxes equals question mark, and number of small boxes equals question mark. Okay, so I've got my units. The units are boxes. Looks like I've got L and S for my variables. So I'll say L equals number of large boxes. S equals number of small boxes. Okay, so I've written down what I'm trying to find. I've defined the variables, and again, from defining the variables, you can get the sum equation. So let's see if there's a sum of boxes anywhere. Right here. Okay, so for my sum equation, it's going to be L plus S equals 125. Then to the rate equation, go to the other sentences. 60L plus 20S equals 5,300. 60L plus 20S equals 5,300. Now in this example, we're actually going to solve and find out how many. Okay, and that's what you have to do on Alex. All right, so I got two equations and two unknowns. I could do substitution or elimination. Many students prefer substitution, so we'll do that. So I'll just say L equals 125 minus S. Okay, I just subtracted S from each side. Then wherever I see an L, I will replace it with 125 minus S. So this equation over here will now turn into 60 times 125 minus S plus 20S equals 5,300. I now have one equation and one unknown, so I can now distribute. So that's going to be 7,500 minus 60S plus 20S equals 5,300. Combining the terms, 7,500 minus 40S equals 5,300. I could subtract 7,500 from each side. Minus 40S equals minus 2,200. A negative, so I'll just divide by negative 40 here. So negative 40 divide by negative 40. So a negative over negative is a positive. I worked this out and I got S equals 55. Okay, then once I get the small boxes, I just put that over here, and then L equals 125 minus 55. So L is gonna, I worked that out, I got 70. And then it's nice to answer in a sentence. So I'll do that right here. So we're gonna have 55 small boxes and 70 large boxes. Whew, this will be the toughest lesson in this unit. So there you have it, how to solve value mixture problems.